Hey kiddos, today you get to see my face too. That's super exciting for you. So what we're going to do today is we're going to take these areas that we found yesterday and we're going to rotate them around different axes. And when we rotate them, they turn into solids. So we're going to be finding volumes instead of areas today. So let me show you how to do it. So they will give you a region, like all of this information was given in the question. They told us that we have this curve, y equals x cubed. They told us that the boundary stops at this line, x equals 2. So we're just looking at this green shaded region. The other thing they will tell us is that we're going to rotate around the x-axis for this question. It'll change. So what we're going to do is we're going to make cuts. And we always want to cut perpendicular to our axis of rotation. So if we're rotating around the x-axis, then our cuts are going to be like here. So I'm going to make a tiny little sliver of a cut there, and I'm going to follow it around the axis. And when I do, if I follow that around, it ends up making a disc. I mean, it's a circle, but it's got a thickness. It's a very, I mean, if it's a really tiny sliver, it's a really tiny sliver of a disc, but it is three-dimensional. So if I were to draw the other end of this in any kind of way, it looks something like this. Like all of these pieces are going around the axis and they're making all of these discs. So this is why you have to see my face today, because I have this. When you're in class, I'll show this to you too, but for today, here's what you got. So this is kind of what our shape looks like. I didn't try to pick something exact. Don't worry about it. But what's going to happen is we're going to pull one of these discs out. So when I pull one of these discs, and we can see it, you can see that it makes a circle, a real, actual, legit circle. And what we're going to do is we're going to try to find the area of one of these circles and then add all of them up. So the way you find the area of a circle, I'm going to talk to you like you don't know anything. Good joke, right? Pi r squared. All right, so the area of one of these circles is going to be pi r squared. R is the radius of your circle, obviously. Well, here's the radii of these circles, and they're all different lengths. So it's not going to be a number inside R. But if you look at that distance that it's covering, it's always going from curve. So this would be pi, and our curve is x cubed minus 0 is that distance. I know you hate writing minus 0, but trust me, it's not always going to be 0. So you're going top minus bottom to find a vertical distance. The top of that radius is on our curve of x cubed. The bottom of that radius is on the axis, y equals 0, so x cubed minus 0. And then that gets squared. So that is the area of one circle. We don't want one circle, we want all of the circles. So what we do is we add up all of the circles. I'm going to put the pi outside because I always will. X cubed squared is to the 6th. And then our last piece that we need is where should we start adding circles and where should we stop adding circles? And for this question, it's going to be 0 to 2. Of course, you can take that integral. It's add 1, divide by the new, plug in 2, plug in 0. Don't lose your pi. I'm pretty sure your deltas allow you the use of a calculator and even ask you to round to 3 decimal places. So practice taking integrals in your calculator. Here's another one. So our curve is a little bit more exciting. Doesn't matter. We're just going to do setup here together. You see your green shaded region that's going to get rotated. This time we're going to rotate around this line here that they've drawn, this y equals 4 line. So again, if I cut a sliver and I follow it around our axis of rotation, it's going to come up here and then go back into my screen and around the other side. We're still making circles. You're always making circles. You're always making circles. So we're going to have another pi r squared to find the area of 1. But this time your radius, you've got to be careful. Your radius is this red sliver that you've just cut. So this vertical length here. The way you calculate a vertical distance is top minus bottom. This time top is 4. Bottom is the curve e to the, e to the x minus 1. So that whole thing is your radius, and that gets squared. Of course, we're going to clean it up. There's a pi. 4 minus negative 1 is 4 plus 1, which is 5, minus e to the x all squared. And then that's the area of 1. We don't want the area of 1. We want the volume of all of them. So we're going to add all. I'm going to put a pi outside. 5 minus e to the x dx. dx is actually your thickness here. And then this one, my bounds are going to start at 0, and they're going to stop here. So I have a little bit of work to do because I have to find that x value where these things stop. No, you don't get to say, it looks like 1.6. You can't do that. So we're going to go find it algebraically by setting our curves equal and finding their intersection. So e to the x minus 1 equals 4. So e to the x equals 5. The inverse of e to the x is natural log. I'm sighing heavily because I hate that you don't know that. So natural log of 5. So we're going to natural log of 5. What I did was I logged both sides of this. The end. Again, you have a calculator for these, so feel free to practice typing. If you need a calculator at home to do this, then I suggest you contact me and rent one. All right, kids, let me know if you need anything.